In this video, we will learn more about frictional force, rolling friction. The force of friction that comes into play when a body rolls over the surface of another body is called rolling frictional force. When a wheel rolls over a road, the rolling friction comes into play. For the same magnitude of normal reaction, rolling friction is always much smaller than the sliding friction. And by following the same rules, the rolling friction force will be directly proportional to the normal reaction, and when you remove the sign, you will get a directly proportional constant, and that is the coefficient of rolling friction denoted by mu r. Cause of rolling friction. Consider a wheel rolling along a road. As the wheel rolls, it exerts a large pressure due to its small area. This causes a slight depression of the road below and a small elevation or mount in front of it. In addition to this, the rolling wheel has to continuously detach itself from the surface on which it rolls. This is opposed by the adhesive force between the two surfaces in contact. On account of both of these factors, a force originates which retards the rolling motion, and this retarding force is known as rolling friction. On the same basis, the laws of rolling friction says that it is directly proportional to normal reaction and is inversely proportional to the radius of the rolling cylinder or wheel. Now, why there is a need to convert kinetic friction into rolling friction? Because when a wheel rolls without slipping over a horizontal plane, the surfaces at contact do not rub each other. The relative velocity of the point of contact of the wheel with respect to the plane is zero if there is no slipping. There is no sliding or static friction in such an ideal situation. We need to overcome rolling friction only, which is much smaller than the sliding frictional force. That's why wheel has been considered as one of the greatest inventions. Now, friction is a necessary evil. In many situations, friction has a negative role. It opposes relative motion and hence dissipates more power in the form of heat, like a machine with different moving parts. It causes wear and tear of machinery parts in contact. But in many practical situations, friction is critically needed. For example, brakes in machines and automobiles use friction to stop the motion. We cannot walk without sufficient friction, and it is impossible for a car to move on the slippery roads. On an ordinary road, the friction between the tire and the road provides the necessary external force to accelerate the car. So, although frictional force is a non-conservative force and causes lots of wastage of energy in the form of heat, yet it is very useful to use in many ways. That's why it is considered as a necessary evil. The methods of reducing friction: by polishing, by proper selection of material, and by lubrication, we can reduce the frictional force. Ball bearings can be used to reduce the friction since the rolling friction is less. And the following diagrams in A, ball bearings placed between moving parts of the machine has been shown, and the second diagram shows the compressed cushion of air between surfaces in relative motion to reduce the friction. Let's solve a numerical on the content. Till now we have studied about the frictional force. It is in NCERT example 5.7. You have to determine the maximum acceleration of the train in which a box lying on its floor will remain stationary. And it is given that the coefficient of static friction between the box and the train's floor is 0.15. Since the acceleration of the box is due to the static friction force, so MA will be equals to Fs, which is less than equals to mu s n, means mu s ng, means acceleration is less than mu s into g. So A max will be equals to mu s into g, and by putting the value of, you will get the maximum acceleration as 1.5 meter per second square. Another example. What is the acceleration of the block and trolley system shown in figure A if the coefficient of kinetic friction between the trolley and the surface is 0.04? What is the tension in the string? And you have to neglect the mass of the string and take the value of G as 10 meter per second square. Because the string is inextensible and the pulley is smooth, the 3 kilogram block and 20 kilogram trolley both have the same magnitude of acceleration. Applying Newton's second law, 30 minus the tension will give you the net force, and that is 3A. Apply the second law of motion on the trolley. As shown in the figure C, T minus Fk will be the 20A, and now Fk, you know that it is mu k into the normal reaction, and the value of coefficient of kinetic frictional force is given to you, that is 0.04, and the normal reaction will be mass into acceleration due to gravity, so 20 into 10, 200 Newton. Thus, the equation for the motion of the trolley will be T minus 0.04 into 200 will be equals to 20A. And on solving it, you will get acceleration equals to 0.96 meter per second square and the tension 27.1 Newton.